vertical hyperbola with center not at the origin.
The equation of a vertical hyperbola with center not at the origin is quantity y minus k squared over a squared minus quantity x minus h squared over b squared equals 1.
Here is a Cartesian plane.
Let's plot a point h, k that serves as the center of a vertical hyperbola.
Since a vertical hyperbola, the openings are upward and downward directions.
Also, the transverse axis is the vertical line passing the point h, k, so the transverse axis is the line with equation x equals h.
The intersection of the transverse axis and hyperbola are the two vertices.
Let A be the distance from the center to the vertices. The distance from the x-axis to the center is k, and the distance from center to the upper vertex is a, and since x here is steady, so the coordinates of the upper vertex is h, k plus a.
For the lower vertex, it's k
minus a.
So the coordinates of the lower vertex is h, k minus a.
The same happens for the two foci. The distance from the center to the upper and lower endpoints is c, so the upper focus has the coordinates h, k plus c, and the lower foci has the coordinates h, k minus c.
Plot a point at the upper vertex with distance b to the right.
This point has the coordinates h plus b, k plus a.
And also to the left with distance b, so the coordinate is h minus b, k plus a.
And also on the lower vertex.
This is having the coordinates h minus b, k minus a.
And also to the right.
This is having the coordinate h plus b, k minus a.
After plotting these points, connect forming a rectangle. The distance between 2 points horizontally is 2b,
while the distance between 2 points vertically is 2a. Now we are going to draw a diagonal line passing through the center as our first asymptote.
By point slope form, we have y minus k equals a over b times quantity x minus h as the equation of this line.
Opposite in direction to this line. Draw another diagonal line intersecting at the
this
center. Horizontal
Since
line passing through the center is the conjugate axis with the equation
y minus
y
k
equals k.
negative a over b times quantity x minus h.
This is the second asymptote line. Example, sketch the graph of the hyperbola with equation quantity y minus 6 squared over 9 minus quantity x minus 5 squared over 16 equals 1.
From this equation, a squared equals 9 and b squared equals 16.
Getting the square root, we have a equals plus and minus 3 and b equals plus and minus 4.
We have also c squared equals a squared plus b squared, so c squared equals 9 plus 16, so c squared equals 25.
Getting the square root, we have c equals plus and minus 5. From the equation of the hyperbola, the center has the coordinates h, k. In this case, the center has the coordinates 5, 6.
For the upper vertex, v sub to the coordinates h, k plus a. So we have v sub 2 is 5, 6 plus 3, v sub 2 has the coordinates 5, 9. For v sub 1, the lower vertex h, k minus a, so v sub 1, 5, 6 minus 3, so v sub 1 has coordinates 5, 3.
For the upper focus, f sub 2 is h, k plus c, so f sub 2, 5, 6 plus 5, so f sub 2 has coordinates 5, 11. For the lower focus f sub 1, we h, k minus c, so 5, 6 minus 5, so f sub 1 has the coordinates 5, 1.
For the equation of the asymptote lines, we have y minus k equals a over b times quantity x minus h.
Substitute the derived values, we have y minus 6 equals 3 over 4 times quantity x minus 5.
Transpose 4 to the left as multiplier, so we have 4 times quantity y minus 6 equals 3 times quantity x minus 5.
Using distributive property of multiplication, we have for y minus 24 equals 3x minus 15. Transpose 24 to the right, so for y equals 3x minus 15 plus 24, so for y equals 3x plus 9.
This is the first asymptote.
For the second asymptote, we have y minus k equals negative a over b times quantity x minus h.
Substitute the derived values. We have y minus 6 equals negative 3 over 4 times quantity x minus 5.
Transpose 4 to the left as multiplier, so 4 times quantity y minus 6 equals negative 3 times quantity x minus 5.
By distributive property, we have for y minus 24 equals negative 3x plus 15.
Transpose 24 to the right, so we have 4y equals negative 3x plus 15 plus 24, so 4y equals negative 3x plus 39.
This is the second asymptote. Using Cartesian plane, we are going to sketch the graph. First, plot the center 5, 6. The upper and low vertices 5, 9 and 5, 3.
For the two foci, we have 5, 11 and 5, 1.
Connecting these points, we have our transverse axis x equals 5, and the conjugate axis is y equals 6.
The first asymptote line with the equation for y equals 3x plus 9.
And the second asymptote line with the equation for y equals negative 3x plus 39.
Using the vertices and the asymptote lines as guides to the opening of the hyperbola, here is now the hyperbola.